Hello, math people. In this video, we're going to talk about partial fractions, which is a technique of integration that you learn often in Calculus 2. So shown here on the screen is one example of an integral that we could use partial fractions on. We have the integral of 5x minus 3 over x squared minus 9 dx. So I say that this is a candidate for using partial fractions because we have a polynomial up top and a polynomial on the bottom, and the degree of the polynomial in the numerator is 1. The degree of the polynomial in the denominator is 2. And in particular, we need the degree of the polynomial in the denominator to be greater than the degree of the polynomial in the numerator. Okay, so now that we know that we can use partial fractions on this, let's talk about how we'll do that. First thing that's useful for this is to factor the denominator. So let's factor this into x plus 3 times x minus 3. Now what we're going to do is rewrite this as something on top over x plus 3. We're going to integrate that, and then we're going to add on b over x minus 3 and integrate that. The question is, what's a and what is b in order for this to work out? So we need to find a and b, but first let's quick talk about why we would want to do that. If we look at our original integral right here, we don't know how to integrate that. However, if we look at a over x plus 3, we can definitely integrate that. And if we look at b over x minus 3, we can also definitely easily integrate that. So this is nice and easy. This is nice and easy. This we may have some sort of feeling about, but no worries because we can turn our left-hand side into our right-hand side. Okay, so in order to figure out what the a and b values are, we need to just set the left-hand side and the right-hand side of this equal to each other. So let's just take the integrand, 5x minus 3 divided by x plus 3, x minus 3. And we're going to set that equal to the integrand of a over x plus 3, and then the other integrand of b over x minus 3. So we're going to set these equal, and we're going to solve for a and b. So first thing we're going to do to solve is multiply this denominator over to the other two fractions. So that leaves 5x minus 3 equals a times x plus 3, x minus 3 over x plus 3 plus b times x plus 3, x minus 3 divided by x minus 3. And now right away we can see that our x plus 3's cancel and our x minus 3's cancel. So this simplifies a bunch. We get ax minus 3a plus bx plus 3b is equal to 5x minus 3. Let's now collect the like terms. So we can see we have ax and we have a bx, so let's add those together. We have a plus b times x, and then we have plus 3b minus 3a. Okay, now what we're going to do is check out the left-hand side and the right-hand side. In particular, this 5 must be equal to a plus b because we have 5x and then a plus b x. So 5 must be equal to a plus b. Similarly, negative 3 must be equal to 3b minus 3a. So now we have two equations and two unknowns, so we can go ahead and solve. And I'm just going to start here. You can start with either one, but I'll start with -3 equals 3b minus 3a. Going to divide both sides by -3. So that gives us 1 is equal to -b plus a. Or in other words, a is equal to b plus 1. All right, so we're getting somewhere. We know that a is equal to b plus 1, and we have one more equation that we can use. Let's now work with this pink equation, and we're going to sub a equals b plus 1 into the pink equation. So 5 is equal to a plus b, but a is equal to b plus 1. So 5 is equal to b plus 1 plus b. That means that 4 is equal to 2b, and b is equal to 2. So b equals 2, a equals b plus 1. So a is equal to 3. Now we have the two constants that we need. We can come back to this setup right here. So now we can see that a was equal to 3, b was equal to 2. So let's go ahead and sub those in. Now let's go ahead and evaluate those integrals. So for the first one, if we want, we could pull the 3 out in front. And for the second one, we can pull the 2 out in front. And here we can use u substitution with u equals x plus 3, du equals dx. And then for our second one, we can use u equals x minus 3, du is equal to dx. And then what we end up getting is that the integral 5x minus 3 over x squared minus 9 dx is equal to 3 times the natural log of x plus 3 plus 2 times the natural log of x minus 3 plus our constant. So this is our final answer here. And we can always check our work. So we could take the derivative of the right-hand side. So if we look at d dx of 3 natural log of x plus 3 plus 2 natural log of x minus 3 plus our constant. We know that the natural log of x plus 3 has derivative 1 over x plus 3. And the derivative of the natural log of x minus 3 is 1 over x minus 3. So that is great because that is what we started with up here. Similarly, we could also check our work with the a and b values. If we're not feeling confident, we can always check our work, and it's a good idea even if you are confident. So we said that 3 over x plus 3 plus 2 over x minus 3. We want to check to make sure that is equal to our original 5x minus 3 over x squared minus 9. So we can check this nice and easily. Let's go ahead and find a common denominator on the left-hand side. So 3 times x minus 3 over x plus 3, x minus 3, plus 2 times x plus 3 over x minus 3, x plus 3. So now we have our common denominator, which is x squared minus 9. And let's go ahead and expand the numerator. We have 3x minus 9 plus 2x plus 2 times 3, 6. Okay, combine our like terms, we get 5x, and then we have negative 9 plus 6, or minus 3. So we checked our work, and it looks like our work for our partial fractions looks great. And then earlier, we checked our work for our derivative, and we saw that the derivative looks great as well. So that's an example of partial fractions. Hopefully that helps when you're working on some future problems. Good luck.